Outliers are extreme numbers, but we need some really methodical and numeric method for determining what's an outlier and what isn't. For example, here's a data set, and we have 11 numbers, and this last number is 42. That seems pretty out of whack from the other ones. But how do we actually make a calculated assessment as to whether this is an outlier? There are actually really two ways of doing this. This video is going to show you the way based on the 5-number summary. Once we've studied about standard deviation, there's a second method that we'll use with standard deviation. But here we have our 5-number summary. So of course this is our min. Oops, let me get the colors on there. So this is the min, right? Of course this is our max. 11 numbers, so 1, 2, 3, 4, 5, 6th one will be the median. And then of course, middle again is first quartile, and middle again is third quartile of these lower 5 and upper 5. So we have our inner quartile range, which we will need. So the IQR is, of course, 11 minus 5. So the IQR is 6. So what we need is some boundaries to define outliers. So there's going to be a lower boundary, right? If the lower boundary was 2.5, for example, then 2 would be outside the boundary and would be an outlier. If the lower boundary was 1.5, then 2 wouldn't be over the outlier or over the boundary, and it wouldn't be an outlier. And the same thing, we'll have an upper boundary up here as well. So the definition, we have, let's, I guess, calculate lower limit. Right. Because it's on the lower side, you start from the first quartile. So this is going to be Q1 minus, because of course we're going this way on the number line, 1.5 times the inner quartile range. So lower limit in this case is going to be 5 minus 1.5 times 6. Which of course will be 5 minus 9, which would be negative 4. So the lower limit's negative 4. Do we have any values less than negative 4? No. So there aren't any outliers on the low end. Well, let's check the upper limit. That, and actually I forgot, that's Q1. It starts from the first quartile and extends, in the negative direction. This is going to start at the third quartile and extend in the positive direction. The same distance of 1.5 of IQR, essentially 50% larger than the length of the IQR. So the upper limit in this case is going to be 11 plus 1.5 times 6. All right, upper limit is 11 plus 9. So the upper limit is a nice round 20. So what that does is it creates, the boundary of, this is the upper limit. So this 42 is on the other side, so we have identified one outlier. So, oops. All right, outliers, right, is 42 because 42 is larger than the upper limit. And that's how you find outliers using the 5-number summary. Now, once you have identified an outlier like 42, we have to be a little bit careful. You don't eliminate the outliers. They're just unusual values. What you want to do is look back at your data and just evaluate to see if there was a simple mistake. A classic example is that, if these were like 0.2, 0.3, 0.5, 1.1, 1.2, well, was this meant to be 4.2 and someone just forgot the decimal point? And so you can trace, if there was a simple, input error. But if it was a legitimate measured value, you do not get rid of it. It just raises a flag so that you can investigate. And until we learn about standard deviation, this is how you identify outliers.